Now, unit is always accompanied by dimension. If you recall, I gave you 7 fundamental units previously. Following LM theta, we know that length, the L there stands for length, which is measured in meter. The M stands for mass, which is measured in kilogram. That's the unit for mass. Then time. The unit for time is seconds. Unit of electric current is ampere. Unit for temperature is Kelvin. That of amount of substance is mole. And that of luminous intensity is candela. We remove the last two, mole and candela. Let's work with these 5. These are the fundamental units. I told you units are always accompanied by dimensions. Look at the dimension for meter being a unit is coming from the quantity that is measured in meter itself, which is length. First letter in length, in the word length, is L. So we have the dimension to be capital letter L like this. We're enclosing a square bracket. That of kg, you know kg is the unit for mass. The first letter in the word mass is m, so the dimension will be capital letter M as well. That of time will be then seconds for time. You know, the first letter in time is T. So we have that for the first 3, which is coming from the first letter of their usual physical quantity. Now, ampere, which is the unit for electric current, is having the dimension capital letter I. Take note of this. I is the dimension for electric currents. While that of temperature is having its dimension to be theta. Please get used to this because we are going to be needing this for the next study, which is dimensional analysis. So then, it will give you force, which is measured in Newton, and it's having its fundamental equivalent to be in kilogram meter per second square. That is product of mass times acceleration. This is just the unit representation. It will now ask you to get the dimension for force. The dimension will change to, you see this kg here, is having the dimension of m. So you represent this with what? M. The meter here, of course, meter will be changed to dimension L. Then seconds will be changed to dimension T, which is raised to the power of -2. So we have it like this. The above one here is the unit, while this is the dimension. So guys, I need you to do something very quickly for me. Go to this comment section now and tell me what the dimension of pressure will be. What then will the dimension of pressure be? Drop that on the comment section. If you are yet to subscribe to this channel, why not go and click the subscribe button? Click the subscribe button. Make sure you are subscribed to Physics Classroom. And don't forget to turn on the notification bell so that anytime I upload a new video, you get to benefit from it. You get to know on time. Do that quickly. And if you've been gaining immensely, just try and give us a thumb up. Hit the like button as well. God bless you as you do so. Let's move to the next aspect, which is dimensional analysis. What is dimensional analysis? Dimensional analysis refers to the expression of physical quantities in their dimension in order to test the validity of the physical equation. There is no way we can carry out dimensional analysis without having a physical equation. The physical equation will now comprise of various dimensional or physical quantities. Hope you understand. What I'm saying is this. You are all familiar with equation of motion. We have one of the equations of motion to be V is equal to U plus AT. This is a physical quantity, which is final velocity. This is another physical quantity, initial velocity. A here is a physical quantity, which stands for acceleration, while T is another physical quantity that stands for time. So when I say dimensional analysis refer to the expression of physical quantities in their dimension. Of course, we're going to bring them to their dimensional form in order to test what? In order to do what? Where's the aim? In order to test the validity of the physical equation. We have physical equation like this when we have something to the right and something to the left. Then we have this equal to symbol connecting the left hand side to the right hand side. Then we call it an equation. Once you have the equal to sign, then we've established an equation, and that is what dimensional analysis is all about. So here, if I want to, they can ask you to test the correctness of the above equation, the above physical equation. To do this, it's easy. Velocity, final velocity is measured in meter per second. So the dimension for that velocity will be Lt raised to the power of -1 meter per second. Meter is having the dimension L, while second is having the dimension T. We have it like this. Equals to that of initial velocity will still be the same thing. Lt raised to the power of -1. You see, in dimensional analysis, when you have plus or minus, it will invariably change to what? Equal to when carrying out the dimensional analysis proper. But when we have multiplication and division, we use them as such. We treat them as multiplication and division, respectively. Hope you understand. So for plus or minus, it will be changed automatically to equal to. Now, dimension for acceleration, that's Lt raised to the power of -2 times that of time, t. So this will give us Lt raised to the power of -1. Now let's try and compare. This is equal to this, equal to this. Since the three are all equal, we say the equation is dimensionally correct. So that's how we test the validity of the physical equation. I'll be giving you more examples just to get yourself familiar with dimensional analysis. Another example is as shown on the board. It says, show that the equation Ft is equal to mv minus mu. Show that that equation is dimensionally consistent. It's very easy to do. Solution to this problem. The equation is Ft, that is product of force times time, is equal to product of mass times final velocity minus mass times initial velocity. Simple. Mind you, we are having negative sign here. In dimensional analysis, what did I tell you we always do? We change this one, we change it to equal to. So the equation will be transformed to Ft is equal to mv is equal to mu. Then we go on to prove that they are dimensionally correct. Now, force is having a dimension mlt raised to the power of -2 times that of time is having a dimension of t. When you join these two together, you'll be having the dimension mlt raised to the power of what? -1. That is for the first is equal to mass. The dimension for mass is m, while that of velocity is Lt raised to the power of -1. The same applies to mass times initial velocity. That's mLt raised to the power of -1. If you look at the three equations, the three brackets, you find out that we have the same entities all through. mLt raised to the power of -1, mLt raised to the power of -1, mLt raised to the power of -1. Since they are all equal, we say the equation, the above equation is dimensionally consistent or correct, or the equation is valid. Anyone you choose to use. Now, let me give you two other questions that are relevant to this aspect, dimensional analysis. The first one, which says the value of x, y, and z respectively in the expression m raised to the power of x, l raised to the power of y, t raised to the power of z for the universal gravitational constant g are, they gave you options. Let's quickly do this. Solution to the problem. Solution to the problem. See, since they are talking about universal gravitational constant g, we can easily adopt the equation from Newton's law of universal gravitation, which states that the gravitational force of attraction is directly proportional to the product of the masses of two bodies, m1 times m2, but inversely proportional to the square of the distance separating the two bodies. So from here, we can easily see F is equal to that universal gravitational constant m1 times m2 all over r squared. So we can adopt it from here. So to make G, the gravitational constant, the sorry formula here, we are going to cross multiply. By virtue of that, we have our fr squared to be equal to gm1 m2. We can decide to divide through by m1 m2 such that this will cancel this. Therefore, our G to be equal to fr squared all over m1 m2, which can still be our F, is measured in kilogram meter per second squared, dot the R is measured in meter, don't put square as shown here, over M1 is measured in kg. Likewise, M2 is also measured in kg. So this cancels one of these. What we have here can now be expressed as per kilogram, this times this, meter cube per second square. In its dimensional form, it will change to m raised to the power of minus 1, L raised to the power of 3, T raised to the power of minus 2. So if we compare it with m raised to the power of x, our x now will be equal to minus 1, comma, y will be equal to 3. We are comparing this with this, equal to 3, and the t, which is z now, z will be equals to minus 2. So our final answer would be minus 1, 3, and minus 2 respectively for x, y, and z. Minus 1, 3, minus 2. Minus 1, 3, and minus 2. That is option B, which is correct. Then we'll move to the next question, question 2, which says, at what respective values of x, y, and z would the unit of force be dimensionally equivalent to m raised to the power x, L raised to the power y, T raised to the power of z? That one is also very easy to solve. We just recall that force is derived from the product of mass and acceleration, and the dimension as such becomes mlt raised to the power of minus 2. We just compare with this. This m is raised to the power of 1. Likewise, the L raised to the power of 1 as well. So when we compare, we know that our x will be equal to what? 1, comma, L. Compare with this. The y now is equal to 1 as well. Then, last but not the least, the z. Z equals to what? Minus 2. So our final answer in this regard will be 1, 1, minus 2 for x, y, and z respectively. 1, 1, minus 2, and that brings us to option D, which will be the answer. If you have not yet subscribed to the channel, hit the subscribe button, then turn on the notification bell so that it will keep you informed anytime we post or upload our new video. You can't afford to miss this if you are a physics student. By the special grace of God, every week we'll be uploading new sets of videos. So please stay tuned to this channel. And if you know you've gained one thing or the other, don't hesitate to like the video, then share the video so that other people can benefit from this. See you in our next video. Stay blessed.